Hey everybody, Mike here. So I am back to my rectangle dish teardown. If you remember in my last video, I kind of did an unboxing of this guy and I showed some pictures of somebody else's teardown. And I didn't actually tear this one down on that video because I, one, wanted to make sure that it worked, and two, I wanted to be very careful about how I did the teardown on this because I want to actually use this as a flat panel for portable operation. So if you haven't seen my other videos, I took a round dish quite a while ago and did a teardown, made it nice and flat, and mounted a magnetic mount on here. The magnets let me mount it to the roof of my car and tested driving around for mobility, which worked awesome. Check out the video here if you haven't already. An update on that test. The magnets, while they held really well, did not hold without problems. So suffice it to say, I was going pretty fast and it was a windy day and it actually did slip. It released. And I got some pictures here of kind of the aftermath. So you can see it was on the roof, and then from these pictures, it actually was near the back of the car. And from what I can tell, based on the sound and the fact that there's a great big black mark on the top, this whole dish flipped off the roof upside down and then flipped over again to land on the back of the car. And so I got the big black smudge on here, which I think was from the antenna, the FM radio antenna on the top of my car, which from the pictures you can now see is completely missing. It just got sheared right off and is somewhere on the highway. So thankfully the white ropes saved the dish, but you can actually see that force frayed the outer case there quite a bit. So I'm probably lucky that they didn't get sliced right through by the sharp corners of the aluminum angle here. But it was survived. I had enough slack in the Ethernet cord that it didn't get teared out. So besides some extra dents and the missing antenna off the top of my car, I think I made out pretty well there. But all that to say that this is still a pretty heavy unit. And because of the profile, the mounting studs and everything, it's hard to get it actually flush with the top of the car without actually cutting a hole in the top of a car, which somebody's actually done with a truck. I'll put up some pictures here. That's ultra low profile, but my wife wouldn't let me cut a round hole in the roof of the car just yet anyway. So that brings us to today's project. So the rectangle dish is much lighter and much smaller. And as we saw from the teardown in the last video, it doesn't have that metal backplane. So it should be possible to actually get this extremely low profile to cut out wind kind of lift and really make this a compact unit. So the reason I hesitated and took a bit of extra time is because I want to actually cut this plastic in such a way that it lets me use the dish and really damage it as little as possible so that it continue to work and be reliably mounted into something a bit more rugged than the chopped up back and the open exposed PCB back here. So what I'm thinking, and this may change over the course of the video, is you can see on the top here that let me try to get it oriented so you can see it. There's a gray side and then the white side, and the white side has this shoulder. And what I want to try to do is cut off the plastic backplane right at the top of that shoulder so that we get a nice, clean, flat top edge. You know, if you're looking at it this way, without all this bulk, all that will be removed. So I debated a couple different ways of doing this. My first thought was actually running it through a rotor set up almost like a jointer to completely remove the outer edge. You can see the vinyl cover and then the gray. Basically rotor off everything, including that gray edge. But I didn't like that because it chews into the gray plastic and I didn't know how resilient it would be if it would get torn out. So what I thought at least starting with is attacking the white plastic and then leaving the gray stuff intact. So what I'm going to try, and this will probably make more sense when you see the setup, is this is a Dremel plastic cutting disc. Just a tiny thing, but it's got a bit of a reach. And what I'm going to do is set it up actually upside down in a drill press. You'll see that in a second. And run this through on the table so that this cutting wheel cuts into there just at that fold over edge. And the goal there is that we get a nice clean cut so that if we need to glue anything to it or mount it or press against it in any way, we get a nice flat edge. And that the cutting wheel should be able to cut into this plastic without kind of cracking it and tearing it all apart. I also want to get really accurate measurements of the dimensions of this thing so that this white backplate has a lot of little fingers that reach down to the PCB to hold everything in place to make it rigid against pressure on the front. I want to make sure I understand exactly where those are and how far they reach down so that I can reproduce a backplate that will give the PCB the support that it needs. So, a lot of unknowns here, but I want to try it out. So let's go to the garage and take a look at it. Okay, so like I said on the intro, what I've got set up is this Dremel cutting wheel. It's a plastic cutting wheel. And I've got the table for my drill press and that in the chuck so that the surface of the table and the bottom of that cutting edge are just lined up to hit that white shoulder so that when I come on here against the table and slide it in, what I want it to do is just take off at the start of that edge there. I don't know if this is going to work. It's my only rectangle dish, so here's hoping. Safety goggles on. I'm probably not going to be able to talk. The drill press will be a bit loud, but we'll give it a try and see how it goes. Should mention, I've got the drill press set to its highest speed because the Dremel is designed to spin quite fast. So I think that'll probably work the best here. But again, we'll see. Check that out. Looks like it's cutting pretty smoothly actually. Just gonna go a bit deeper. And what I want to do is just verify that I'm not hitting the PCB. That stinks quite a bit. Okay, I've just broken through and the plastic offcuts kind of gum things up, but what I want to do is just take a really close look in here to make sure that I've cleared the circuit board and that I'm not cutting into any components or anything like that. Okay, it looks okay, but I don't have a really clear view in there, so I'm going to go a little bit further and see how it goes. Okay, first side done, and actually went pretty smoothly. A little tricky to make sure that it's flat against the table all the time. So I'm sure when I'm done there'll be a little bit of wobble on here, but overall pretty good. I'm still hopeful I'm not cutting into the PCB, but so far all the stuff falling off appears to just be plastic. No bits of FR4 or anything like that. So Fingers crossed. So what I'm going to do now, so I've done all the side, I'm going to switch it over and do this side, just so that the motors, I want to do the short side last so that when the top is a bit wobbly, I've got the shortest distance to actually finish before it comes loose. So I might even kind of go around the corners a bit and then around this side so that it's just a snip at the end. Here we go. Okay, that side's looking good. I think I might have actually hit a component though, right at that last corner. I can't see what it is yet, but I think I might have gone a bit too deep there. Hope it wasn't anything that's gonna break it. Okay, so that's two sides done. Oh yeah, I think I might have hit something. Uh-oh. Okay, well, I'll just have to keep going and hope that whatever it is either wasn't damaged or that I can replace it. Okay, let's try. Okay, so I'm not quite all the way through on this corner, but I'm going to leave it until I do the other side. Those little attachment points might help hold the whole thing together while I finish this even side. Okay, last full end. All right, that is all the way around. Now, it hasn't just popped off, so I imagine there's still a couple connection points I have to clear, but I'm going to go very gently here. So this corner here looks like it needs some work. That was what it took. Here we go. Okay, so before I look, I definitely hit some things. Okay, let's take a look. I'm gonna loosen the connectors. And ta-da! All right. Look at that. Woo! All right, okay. So, quick look. Oh, I am very close to the PCB here. Definitely one place where I shaved off some of the resist and maybe some traces. And I think over here I definitely hit a part. Looks like maybe a capacitor. Oh wow, will you look at that. Beautiful. Okay, but I need to test this to see if it still works. And there's the underside of that too. So this is good. I managed to preserve the position of all these little standoffs and the little fingers here so that we know exactly where they touch down on the circuit board. I'm going to be able to measure in and get pretty accurate positions from that. And then on the PCB side, so that a back plate could be manufactured that's completely flat without the bulge on the back for the motors. Awesome. Okay. Looks like this cutter wheel has potential. It definitely seemed to work okay with here. I think the biggest risk is that I nicked something that is gonna be something I need. So I'm gonna do a more detailed inspection here and see how it looks. All right. All right, so the shell is completely removed. Look at that beauty. And look how flat that is. This is much thinner even than the previous one. It's funny, if you look at it, this is probably not going to be in focus, but the highest thing on the board is actually the motor connector. And then the next highest is the Ethernet magnetics. So clearly, with no back, you can actually desolder the motor connector, and it would be right down to that low profile height. So pretty impressive, pretty impressive. I took it outside and gave it a quick test to make sure it all worked, and it didn't. Completely dead. So I did a quick inspection of the board before I tested it, and I actually did hit in a few points. So I'm going to throw up some pictures here. There's one part where I just skimmed the outside edge of the board and it peeled off or scraped off some of the green solder mask. It doesn't look like there were any traces underneath there, so probably no damage there. So that's good. But along this edge, you can see there's very little clearance between the edge of the plastic and the edge of the board. And on the board, there's very little clearance between the edge of the board and the first components. So when I was doing this side, I went in a bit too deep. And there's a few places where I damaged it. Some of these tiny chips, the ones that completely cover the field, I think they're likely amplifier ICs. I skimmed the edge of two of them. It looks like I only hit the encapsulation, so not the actual die inside. I'm hoping that those are going to still work, or at least that the board is tolerant of failures and that if all the other ones are working, it'll still work with maybe just a slightly degraded signal. Probably more relevant though, down on this corner, coming around the corner, in the actual video where I was doing it, I commented on this. I nicked some of these capacitors on this side and on this side. So you can't see the details, but this is where the Ethernet comes in. And there's actually two power supplies in this corner. There's the main one taking the main voltage from the power over Ethernet. And then that's this big coil there. And then there's a smaller one here, which is actually, duplicated in a few places on the board. But coming around that corner, I nicked some of the capacitors on the smaller power supply and one of them on this bigger power supply. And it's completely dead. So I'm going to wrap up this video by saying, wow, this is a super cool low profile board. I think the technique of shaving off the top isn't bad. I think maybe just slightly higher would be required or just not as deep. If you're watching and have any other sort of advice on a better way of kind of tearing this back lid off and really more reliably protecting the board, let me know in the comments down below. I was considering maybe if I had a milling machine that had enough travel to hold this, using like an end mill and just going straight in right over top of this part of the board. And that way you'd get a very precise movement to avoid the PCB. That could be an interesting way to do it. But like I said, if you have any thoughts, suggestions, let me know in the comments down below. You can see here, if I just limited the depth, I wouldn't hit the board at all. I think that's probably a good way forward. The thing I like about it is the front face all the way up to, the factory edge is completely intact. So if you're building an enclosure, which is what I want to do, either maybe initially I'll do like a plexiglass enclosure just to waterproof it, but longer term, maybe a milled aluminum backplate. And that way you could build in some kind of heat dissipation and make it nice and rugged. But it gives you a nice kind of factory edge to measure against. In the green field, you can actually see the little marks on the PCB where the little fingers from the back plate kind of touch down. So what I want to do ultimately, if I do an aluminum milled enclosure, is actually include places to put in little plastic standoffs so that it can provide the same PCB back support that the big case does, but in a much lower profile package. And then I can also mill in some threaded holes to put on magnets or straps or kind of whatever mounting option I want to do at the time. So next video on this teardown is probably going to go full on technical. I'm going to break out the scope and do some diagnostics on the board, figure out whether the power supplies are working. If not, maybe I need to remove and replace those damaged components. So expect a much deeper dive into the circuitry on the board in the next video in this teardown series. I'm so upset with myself that I nicked those parts, but hopefully I'll be able to get it repaired without too much trouble. If you're interested in Starlink, anything to do with outer space, or circuit board diagnostics, definitely subscribe. I've got lots more coming your way. All right, I'm super bummed that I damaged the board in that teardown. I was really hoping I could get this working and do some traveling and testing with it, but it looks like I'm going to have to deep dive into the circuits a bit earlier than I planned. So it is what it is. Thank you very much for watching, and I'll see you next time. Still though, cool.